Yes students, welcome to our new lecture. Today we will conclude the sums of limit by tabular method. Almost 12 sums students we have done of this type, and I hope by this time students all of you are very well versed now in doing this type of sums. So today we are going to conclude this type of sums. Now section E. Students, part 2, we are doing from question 2. We will complete questions 2, 3 and 4. We will complete students questions 2, 3 and 4. And then I am going to explain you a second definition of limit. So, it is based on this tabular method students. So, one has to be very careful and very attentive. Okay students, we have to find the limit by tabular method. So as usual, we will simplify fx. This is fx. So here fx will be twice x square plus 3x minus 5 upon x minus 1. Now students, if I simplify twice x square plus 3x minus 5, 5 into minus 2 is minus 10. So what we will do students, all of you pay attention. So 5 minus 2 will give me 3. So 2x square plus 5x minus 2x minus 5. Take x common, so 2x plus 5. Take minus 1 common, so 2x plus 5. So factors are x minus 1 and 2x plus 5. So this is done as x minus 1 into 2x plus 5 upon x minus 1 gets cancelled. So final function is only 2x plus 5. Then students, as usual, I am writing the steps exactly as given in textbook because we have to understand and write this very perfectly. We shall take the values of x very close to 1 and prepare the following table. We shall take the values of x very close to 1 and the following table is prepared. So here we write x, fx, again x and fx. Draw number line. Say this is 1, left hand side 0, right hand side 2. We can approach 1 students from 2 sides, either from left side or students either from right side. We can approach students 1 from 2 sides, either from left hand side or students from right hand side. This is what students we have to perfectly understand, and then students do the sum. Now students pay attention. Shift point 1 to the left, so it will be 0.9. So the values are 0.9, 0.99, 0.999 and 0.999 onwards. Shift 0.1 to the right, so 1.1, then 1.01, 1.001, 1.0001 and onwards. Check here if I write 0.9, 2 into 0.9 students is how much? then the answer is 1.8. 1.8 plus 5 will be, you can say, 1.8 plus 5 will be 6.8. Then this is 0.99 into 2. Now you know 100 into 2 is 200. So 0.99 into 2 will be 1.9 plus 5. So 6.9. This will be 6.998. This will be 6.9998. And onwards, this is approaching definitely 7. Now when I take 1.1, 2 into 1.1 is 2.2 plus 5. So 7.2. This will be 7.02. 7.002. This will be 7.0002. This is approaching 7. So it is clear from the above table that it is clear from the above table that as the value of x, that the value when the value of x, when the value of x is brought nearer to 1, by increasing or decreasing its value, its values, f of x approaches 7, therefore x tends to 1, then f of x tends to 7, not exactly 7. So the limit of the function 2x squared plus 3x minus 5 upon x minus 1 as x tends to 1 is approximated as 7. Students, limit is never exactly 7, you check. But the approximation of 6.9998 or 7.0002 is written as 7. Students, be very careful. Okay, students, now we are going for the third sum of main question to a negative value sum comes, so you have to be very cautious, students. Now, limit x tends to minus 1, 4x squared plus 5x plus 1. Okay, let us do the necessary changes. Steps are almost same. This will change. Correspondingly, the factorization will change. Okay, sum number 3. It is limit x tends to minus 1. The function is 4x squared plus 5x plus 1 upon x plus 1. So this is 4x squared plus 5x plus 1 upon x plus 1. Factorize 4 to get 5. 4 ones are 4. So 4x squared plus x plus 4x plus 1. Take x common. 4x plus 1. Take 1 common. 4x plus 1. So the factors are x plus 1 and 4x plus 1. So this changes to x plus 1 into 4x plus 1 upon x plus 1 gets cancelled. So net function is only 4x plus 1. So we shall take the values of x close to minus 1 and the following table is prepared. Now let us erase these values and make the table. This much we are changing. Students, it is very tedious to write the statements. Very disgusting to know still few of you are not at all sincere in the lecture of Gujarati and computer. In spite of telling repeatedly, in spite of giving notifications and notice and you can say reminders by Amit sir, please be careful that you attend the lectures of Gujarati and computer because these two subjects also have 100 marks. So if you get 90 in account stats and if you get 50 in Gujarati and 70 or 60 in computer, your overall average will be down. So please be very careful. Now, it is a negative value. Please be careful. Say this is -1, then left side will be -2, right hand side is 0. Now, as you proceed towards more negative numbers, it is less. So when I shift 0.1 to the left, this will be -1.1. Then -1.0, then -1.00, -1.000, and onwards. If I shift 0.1 to the right, then it will be -0.9. Then -0.99, -0.999, -0.9999, and onwards. So negative I have explained yesterday also, today also. I am reiterating, for negative one has to be very cautious. Okay, let us take f of x when it is -1.1. So 4 into -1.1 will be -4.4 and plus 1 will be -3.4. So this first value will be -3.4, then -3.04, then -3.004, -3.004, which is approximated as -3. Same way, 4 into 0.9. Students, pay attention first. 4 into 0.9 will be -3.6. Pay attention, students. 9 4s are 36. So -3.6 plus 1 will be -2.6. Then 99 into 4. 9 4s are 36. 36 into 39. So -3.96 plus 1 will be -2.96. Then -2.996. Then -2.9996. So this is very students close to -3. So it is clear from the above table that when the value of x is brought nearer to -1 by increasing or decreasing its value, then f of x approaches -3. Therefore, as x tends to -1, f of x tends to -3. Therefore, limit as x tends to -1, the given function is nothing but approximated as -3. It is never exactly, students, -3. Clear? All of you understood? So this is how, students, we simplify. Now let us change. The next question. Question number 4. This I'm changing. This also. will change. This also changes. This also changes every time. Now, this also will change. Last question, students, of this type, and I hope that all of you please concentrate. Part 2, question 4. Limit x tends to 0. Dx minus 1. So fx is 3x minus 1. It is 25. We shall take the values of x close to 0 and the following table is prepared. Say this is 0, left side will be minus 1, right side will be plus 1. So, pay attention. Let me check 0 if there is there in the table or not. Yes, example 7. Check. If I shift 0.1 to the left, it will be minus 0.1. Then minus 0.0, then minus 0.001, and then minus 0.001. And if I shift 0.1 to the right, it will be plus 0.1, then 0.01, 0.001, and 0.000, and onwards. Now, students, let us check the corresponding values of f of x when it is minus 0.1, then it is minus 0.3 minus 1, minus 0.3 minus 1, so minus 1.3. Then this will be minus 1.03. This will be minus 1.00. This will be minus 1.000. So this is approaching minus 1. When I take plus 0.1, this is 0.3 minus 1. 0.3 minus 1 will be minus 0.7. Then when I take 0.0, check 3 into 0.01 minus 1, so this is 0.03 minus 1. So this will be minus 0.97. This will be minus 0.997 minus 0.9997. This is also approaching minus 1. So, it is clear from the above table that when the value of x is brought nearer to 0 by increasing or decreasing its value, f of x approaches minus 1. So, x tends to 0, f of x tends to minus 1. So, limit x tends to 0, 3x minus 1 is approximately as minus 1. This is what students we have to understand in this type of questions. So, the second part of the chapter is over, and trust me, the third part of the chapter is very easy. It is based on formulas. The third part of the chapter is very easy, students, because it is based on formulas. And one has to carefully understand and memorize the 3 formulas only for the sums. Now students, today I told you that I will be explaining the second definition of limit, which is based on this particular concept of tabular method. Students, now all of you concentrate. This definition is generally to be written in exam whenever you are asked to define limit of a function. Now trust me, this is very easy. I will explain this 2 to 3 times, so do not worry, students. Now, on on page number 146. Definition. The function f of x has a limit L as x tends to a. Let us take this example. This function f of x is 3x minus 1 has a limit minus 1 as x tends to 0. So in general, what we are telling, the function f of x has a limit L as x tends to a if for each given predetermined epsilon greater than 0, however small, we can find delta such that mod f of x minus L less than epsilon, then for all x such that mod x minus L less than delta. Now students, we have already studied delta neighborhood of A. What does the definition say? For a given predetermined epsilon greater than 0, however we can find a positive number delta such that mod f of x minus L less than epsilon for all x such that mod x minus L less than delta. Now pay attention. Two new words we are introducing. One is epsilon. Check on page number 146. They have given this epsilon. So epsilon, and this is delta. Now students, what does this definition say? That if I want to bring my f of x in the range minus 1.3 to minus 0.7, then students, pay attention, then for this 0, I have to take the values of x as say minus 0.1 and plus 0.1 difference from 0. So students, here all of you just pay attention that when my f of x has to be in the range minus 1.3 to minus 0.7, then the shifting of the value from either side of 0 is 0.1. So my delta will be 0.1 and my epsilon is 0.3. Check. The deviation from minus 1 to the left hand side is also 0.3 and deviation from the minus 1 to the right hand side is also 0.3, because if I subtract 0.3 from minus 1 I will get minus 1.3, and if I add 0.3 to minus 1 I will get minus 0.7. So what we have to remember, that if my epsilon is 0.3, then delta has to be 0.1. Now here minus 1.03 and minus 0.97, so epsilon is 0.03. Then delta has to be 0.01. So epsilon is the delta for fx, and definitely you can say this delta is for A. So it is simply delta neighborhood only, students. Do not worry. If you have not understood this, then did not worry. They have told for a predetermined epsilon greater than 0. So whatever value is other than minus 1, that will become epsilon. So epsilon is 0.3, here it is 0.03, here it is 0.003. And delta, epsilon and delta are positive. So this delta is 0.1, this delta is 0.01, this delta is 0.001. So epsilon and delta, epsilon is always given, epsilon will be predetermined, and based on epsilon students we can find delta. So it is simply to be remembered like this. As such, we have no use of definition in the sum. So the definition reads as follows: the function f of x has limit L as x tends to a if for a predetermined epsilon greater than 0, however small, we can find a positive number delta. If my epsilon is 0.3, then my delta will be 0.1. If my epsilon is 0.03, then my delta will be 0.0. So whatever range we want to get for f of x, correspondingly we have to find the range of x. In whatever range we want to bring f of x, correspondingly we have to find the range of x. So epsilon will be given. Based on epsilon we can find the delta. Epsilon is nothing but delta for f of x. So students, don't worry if you don't understand this definition. Remember 5 points. The limit of the function f of x is L as x tends to a for a given epsilon greater than 0. However small, we can find a corresponding delta greater than 0 such that mod f of x minus L less than epsilon for all x such that mod x minus A less than delta. So for f of x, the delta is epsilon, and for A, the delta is delta itself. So don't worry students, even if you have not understood, this definition has no implication in the sum. Simply we have to work up the definition. Thank you students. We will conclude here the lecture. We will do remaining in the next lecture.